All right, we have example number 1 and example number 3 from unit number 2. We just covered previous video. We just covered displacement and distance, and if you recall, displacement was a vector and a scalar, and distance was the total path length of travel, and displacement is straight line distance, but where you start and where you end. So number 2 and example number 3 are basically just uh, that we can ways that we can reinforce those two concepts. So here's the first one. I have it kind of worked already on a previous video, and it didn't work out, so I had kind of reshooting it the second time, so you guys get to take 2 at least for example number 2. So we have 2 friends travel 2 different routes shown below, both start and stop at the same location. A starts and stops right here, and starts and stops. This is A's route, and B's route is down here. And so if we look at whose distance is greater, obviously I've got B shown already, but let's talk about why. B is going to travel all the way around, and A is going to travel a shorter route. So since route is shorter, we're going to say B's distance is greater. And so displays the distance starting point to the ending point. And, since A and B both start right here and stop right here, the displacement for A is 0 because it starts right here and it ends right here. Remember, displacement isn't concerned about what happens between the beginning and end. It only is concerned about where you start, where you stop, and then draw a straight line, right? So A and the displacement of 0 meters, and so they both the same displacement. All right, example number 2, we're going to look at example number 3, the directions. Use a metric ruler to determine for each measurement or for each movement. So make measurements in centimeters. Be careful to indicate direction. Well, I've already measured them out already, so all we have to do is just go ahead and place them in. Now, keep in mind down below, we've got a D down here that is not bold-faced. It's a regular print, and then we have one here that is, this is going to be our distance, maybe below here, and one's going to be displacement. Okay, so distance is total path, so how far did it travel? Well, it traveled 5 centimeters, so this is going to be 5 centimeters here, and we don't have to be concerned about direction with displacement, right? Distance, but with displacement we do. And so we're going to say 5 centimeters, and then it moved to the right. And so there it is. Part B. Let me zoom in on it a little bit. We start right here, and we finish right here. So displacement is going to be the total path. So we went forward and then up. We don't have the word little sideways part here. I actually meant to put these 2 arrows on top of one another, but for you to be able to see both of them, I kind of had to separate them. So 4 down and 1 up gives us 5 centimeters. And then displacement, it's always going to be from where you start to where you end, but we don't really care what happens in between those 2 points. So we start here and we finish right here. So this is 4 and this is 1. That means that's going to be 3 centimeters. Notice start here and finish down here. So we actually moved down. So that'll be 3 centimeters down. And you're probably noticing that I made a mistake. And no, I didn't. That's 4 and 1. Everything's good. All right, so this is 5 centimeters and then 3 centimeters down. All right, moving along. Total length right here and finish in here. So we're going to start sideways, 3 centimeters down. That gives us 7 centimeters. Total path length is from here to here in a straight line. That's where displacement gets to be kind of sticky. And recognize this is a Pythagorean triple. One side is 3, this is 4 for a right triangle. Then this side will actually be 5 centimeters. We don't have to actually measure that out. So 5 centimeters, and then the direction, you could say southwest, down to the right. For another couple of videos how to actually do that. For now, that'll work just fine. So there's example number 2. Example number 3, the cartoon you'll have to attend class to see. Have a good day.